All right, for 10.1 day 2, we're actually going to be learning about a couple theorems here about tangents. Here are the answers for day 1. Just basically give you guys a chance to practice some of those new vocab words. And you can continue your notes from yesterday. Okay, so the first theorem we have in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Basically, what that means, M is a tangent to the circle if and only if M is perpendicular to QP. This is what you should write down right here. This in the picture, it's more important. So what that allows us to do is it allows us to check and see whether or not a segment or array or line is tangent to a circle. So what we can do is we can apply the converse of the Pythagorean theorem, and we can see if there's a right angle there. So we're basically going to see, is T a right angle, yes or no? So we're going to do the Pythagorean theorem here, or the converse. 12 squared plus 35 squared, is that equal to 37 squared? And you just use a calculator here. 12 squared plus 35 squared is 1369, and 37 squared is 1369. So yes, this would be a right angle there, so that would be a point of tangency. T would be a point of tangency. And it's that simple. Now, you're going to come across questions like this that are a little more complicated, of course, in which we have to use a little bit of algebra from last year. So what we're going to do is 80 squared plus r squared, and then this segment right here is 50 plus r. 50 plus r squared, or r plus 50 squared. Now, you need to know how to square that, and I'm going to show you guys how to do that in case you forgot. So I'm going to go 6400 plus r squared, and then we use our box here, r plus 50, r plus 50, that's r squared, that's 50r, that's 50r, and that is 2500. So we have r squared plus 100r plus 2500. That is squaring a binomial. So the r squareds are gone. I'm going to subtract 2500 from both sides. If this does not make any sense to you, please see me in class for a review on quadratics. 3900 equals 100r. Divide by 100, and r equals 39. There we go. Now, the reason why I was able to do this is because I should have mentioned that B is the point of tangency, so this creates the right triangle there. That's what allowed me to set up the Pythagorean theorem in the first place. I probably should have mentioned that, and I don't think I did. All right, this is a little bit easier. Tangent segment from a common external points are tangent. Basically, if SR and ST are tangent segments, then those two are congruent. Again, just write down this here and the picture there. That's all you need to know. And I'm going to do some sample problems. Let's start with number 9 here. So these are tangents here. So x squared equals 9. And then you can square root both sides. One thing to pay attention to is there's two values that'll make that true, positive 3 and negative 3. And let's see, this one here, if this is 3, this is also 3. So you do 3 squared plus 4 squared, is that equal to 5 squared? And then you check that. Here you do r squared. This one is tangent, so this one's saying that's right angle. R squared plus 24 squared, and then that's equal to r plus 18 squared. And then you would approach this problem here just like the example I just did on the previous slide. So that'd be the setup for those two. All right, we're going to practice this in class. Again, if you need help with those quadratics, please see me so I can assist you. But other than that, hopefully this makes sense, and I will see you guys later.